It's recording now. Go ahead, Chris.
Okay, Allison, can you see my screen?
Yes.
Okay, so start with, why do we exist? Why is Build with Robots a company? It really is less about robots and more about what robots are doing to change the nature of work. And our mission is to make work better for workers. And we see robots as a tool that will allow that to happen. So we want to be part of that solution. We want to make robots a better tool, aligning with the workflow and the uses of what automation brings, essentially making work, really leaning into the dignity and value of workers. And you probably have heard a lot about robots replacing jobs. We don't believe that at all. We actually believe that robots are going to change the world and improve the nature of work and improve the number of jobs. And there's data that shows that. We'll get into that. So we're a startup. Allison mentioned this. We're based in Albuquerque. This shows, actually, this was a few months old. We've hired another 4 or 5 engineers since then, but we're really a high-tech company with mostly engineers and then customer-facing folks, so people that are working with our end customers to use and deploy and just essentially engage with our customers to sell and communicate what robots can do for them in their workflow. So I mentioned this just a second ago, but this really is something that we see happening all around us, is that robots are changing the nature of work, and it's accelerating. And most people see a little bit of this. Since we're in the business, we see it very closely, and it's happening quicker than most people realize. And our belief is over the next 5 to 10 years, robots are going to be pervasive. They're going to change the nature of nearly every industry. And right now, the two on the left, manufacturing and warehousing, is where most of the robotic automation and innovation is happening. But those same tools, that same technology can be applied elsewhere. So we're already doing things in construction, fast food. There's robots already in fast food restaurants. Film and photography are becoming more and more automated. So drones taking video and robot arms holding cameras. Those are happening now, and it's accelerating. It's happening more quickly. And there's many more industries. I can go on and on about the impacts across the board. So the way to think about this, and something you see in some of these pictures, are people. So what's really happened in the last few years is that robots have become safe around people. So 10, 20 years ago, most robots were used in high volume manufacturing. They were essentially dark factories. So people would not be allowed near the robots because they move so fast, they're so heavy, they're essentially dangerous for people to be around. But that's changed. So now robots are smart enough with enough sensors that they can be safe around people. And that changes everything. It allows you to put robots alongside people. And that means that they can be used, well, in all the industries I show here and nearly every other. So here's some data. This chart is probably the most comprehensive look at manufacturing, and it was done through about over 25 years throughout the country of Spain. They tracked all their manufacturing. Spain is really good at tracking data. So they have all this data about who's adopting robots, who's growing, who's adding jobs, who's laying people off, who's going out of business, how much do they use robots, what do they use them for. But the study that was published by one of the large research institutions, Deloitte, they went into this in detail and looked at the data. It was fascinating. So I don't know if you can make out the details on the slides, but that's over from 1990 to 2015. They tracked the companies who invested in automation with those who did not. And it was fascinating. The scale is actually the number of workers. So the companies that actually adopted automation grew more than doubled in the number of workers. They also more than tripled in market share. the amount of business that they had relative to their peers. And the other piece, the companies who were afraid to adopt technology and robotic automation actually shrunk in size and laid people off. And that's, like I said, this is 1990 when robots were not as pervasive as they are today. And this is, 2015, the last 5 years, it's starting to accelerate exponentially. This is happening at an even faster rate today, but it's really changing the economics of business. And the companies that automate are going to get better and faster and cheaper, have higher quality products, more employees, more engaged employees, doing less robotic work, and those who don't will essentially become irrelevant and not be able to compete. And that's, like I said, we've been doing this since for almost 5 years. We've been participating in the automation industry. Build with Robots was started in 2017 because we saw this trend happening, and that's really our mission, is to be part of the solution for the future of our community and our country and our world. So that's essentially what we're doing. So this kind of describes our platform. So you look at all the pieces on the left, the robotics, those are arms mostly. The robotic arm is kind of the workhorse of the robotic industry. There's hundreds of thousands of these robot arms in use worldwide. And they essentially have the same kind of geometries of a human arm, and they kind of do what humans do. But that's changing, because robots don't have to do what humans do. They can do things differently than we do, and that's really the true value. Right below that, you see the autonomous navigation. So these are, think of Amazon warehouses. I showed you, actually, this slide I showed you earlier, that was an Amazon warehouse with their autonomous navigation robots. These robots essentially are ones that can navigate through a building, a facility, see the things around them, avoid obstacles, reroute, remap. So if you're running a large distribution center like Amazon, they move all their goods with autonomous navigation bases. They also do all their bin picking with arms. So an Amazon warehouse looks like people sitting at fixed workstations and robots bringing them packages to pack inside of a box. So the people pack the boxes because people can still do that better than a robot, but all of the goods are brought to them by robots automatically with no intervention. And the robots can store these large distribution centers. They store the goods in random locations. They know where everything is. They know when to reorder. They know where to go put it when it comes in. It's all fully autonomous. And that's done mainly with these autonomous navigation bases. The other thing you probably hear a lot about, I'll combine two of these, data science and artificial intelligence. Probably hear a lot about that. Many of you probably already may even work in those fields. But that the ability to use large data sets to improve your algorithms to do different types of things. We do things like painting, the ability to measure and refine a painting algorithm just by looking at the vast amount of data of what happens when you paint with the robot is also, data's gotten cheap, processing power has gotten extremely cheap, so it's essentially allows you to do things today that you couldn't do even a few years ago. Same thing with sensors. The camera in your phone is a $5 to $10 camera that's more powerful than cameras we had 10 years ago. That cost us $10,000. The most powerful camera 10 years ago can't do what a $5 camera can do today. LiDAR, other types of sensors are also becoming prevalent and ubiquitous because of really because of mobile phones. Most of these sensors are developed for phones, but they can be used in other applications. And then the measurement inspection techniques that are on top of that. So measuring with cameras or other mechanical sound vibration measurements. There's all sorts of other measurement and inspection techniques that are being added. So all of this was being developed mainly for manufacturing. And it was fascinating to us that same technology was really not being used for other industries. And that's our mission. That's why the opportunity we saw, and we wanted to make that intersection of technology and workflow a positive for the workers. Too many of the robot companies are really thinking about replacing people. And we realized that wasn't the real opportunity, because no one wants to be replaced, right? I mean, no one wants to be, and it's also difficult to replace people. People have things like the sense of touch and the integration of pattern recognition and the ability to do very fine motor skills that are expensive, extremely expensive to automate. Whereas there's also things that people do that are very monotonous or dangerous or extremely dirty that robots do very well and people don't want to do. So it's really that intersection of what automation allows you to do with what people don't do very well or people shouldn't be doing because it's dangerous, that we see the opportunity. And that's essentially what we're doing. And you see it on the right, we've launched 3 different in technologies targeted at different industries. So the top one, Kane Robotics, is a joint partnership with a California-based company that serves the aerospace. And we help them develop a sanding and grinding and polishing robot for large structures. So it polishes things like the window sticks for airplanes, the outside structures of rockets that need to be bond prepped, or essentially they need to be sanded before they're glued together, essentially. The second one is a joint partnership. Painting Bots is a joint partnership with one of the world's largest painting brands, and we have an exclusive license to provide automation for on-site construction. And we've been working on that for about a year now and have a prototype that can go into a room and paint a room autonomously. And then the last one, BreezyOne, was our response to COVID. And we have this platform, this know-how, and this great engineering team, and we realized that we can make a difference in the current state of our pandemic. So we rapidly developed and deployed BreezyOne. And I think, yeah, I'll get into BreezyOne. So I kind of went through these already. This shows Kane Aerospace, shows the large robotic arm, has a lift, has a vacuum for picking up dust when you're grinding. This is a large aerostructure. So you see that pattern. That's a pattern of another piece that's going to be glued onto this big carbon fiber plate that's in front of you. And it's essentially, it can autonomously sand and grind that surface for, or any other surface like this. It takes people hours and hours, and it's very dusty and monotonous work to do this. And they can't get enough people to do it because, well, it's not very interesting work, and the robots do it. And the surface finish when the robots do it are better than you could get with a person. So it's a perfect fit for a robot. We talked a little bit about this, autonomous painting at commercial construction sites. So this is our prototype. It can go in and paint a room. It essentially follows walls, detects with LiDAR, detects and sonar, ultrasound, detects objects around it, and navigates in a room and paints the walls, puts down a perfect coating. It's actually, when it paints, the coating it puts down is better than a human can do. It's actually so good that it's hard to touch up. So we're looking at, how do you make it not as perfect, or how do you touch it up in a way that's as perfect as what the robot can do? But it's really interesting, when you apply automation to do things, it really changes the whole equation. Again, commercial construction, prior to COVID, we were short 700,000 construction workers in the U.S., and the paint brand we're working with, they believe they could sell 30% more paint if they had enough workers that were willing to do the monotonous work all day long. They have to wear hazmat suits because they're breathing in paint dust or paint particles. It's not a fun job. I've done it, actually. I painted with a commercial sprayer, and it's very strenuous, it's very monotonous, and it's very dirty. So it's not a great fit for people, but again, great fit for robots. And lastly, so BreezyOne was our response to COVID. And essentially what it is, it's an autonomous robot that can navigate and fog with a high kill rate disinfectant in large spaces. So we're in airports and distribution centers, data centers, large factories. We're looking at trying to get into schools as well. But essentially, think about going in between shifts in a factory or at night at an airport or a school and killing everything and leaving behind a thin layer of protection that also protects those surfaces from spreading any biological pathogens, viruses, bacteria, pollen, molds, anything will be killed and kept safe for up to 21 days after we fogged. And we typically fog nightly, so there's this constant cleaning of the air and the surfaces going on. So let me jump to a video now. Before I do, are there any questions?
Yeah, why don't we pause for a second, see what questions do you have? What surprises you about some of the robots that you've been introduced to so far? All right, I guess we're going to go straight to the video.
Okay, thanks, Allison. So yeah, what I'll do is I'll go ahead and share a video that discusses BreezyOne and a lot of detail, and you'll see it in action and you'll get a better sense of it. I assume you can see my screen?
Yes.
Can you hear the audio?
No.
Okay, let me see how I fix that. I'm going to share just the presentation and see if that fixes the issue.
While we're waiting, somebody is asking a question about the cost of these robots. XD wants to know.
Yeah, good question. So right now we actually lease the robots. So it's essentially a monthly fee. And depending on the number of robots, it's anywhere from $6,000 to $9,000 per month to disinfect a large facility. So that would be something that's the Sunport or a large factory distribution center.
And what about like some of the robotic arms and such?
Say again, sorry, Allison. I was checking to see if audio is working.
Oh yeah. I was asking, what about some of the robotic arms?
So, a typical robotic arm, it would, if you looked at the one that was on the painting robot, it has a reach of about 40 inches, and it can pick up 10 kilos or 22 pounds. So that robot arm is $45,000. There are cheaper knockoff. So that company is kind of the market leader in these industrial grade collaborative robots. And there are knockoffs already. There's, I don't know, maybe 30 different brands of collaborative robots now on the market, and prices are dropping and going down. So that is one of the things, prices keep dropping. The autonomous spaces, from the one we use is from a company called Fetch. There's others. The one Amazon bought the company that they use. Mir is another company. They're all priced around $30,000 at the low end, $30,000 at the low end, up into $70,000 at the high end. autonomous, forklifts are over $100,000. So they're more expensive than a human operated device. So if you think of a forklift, I never priced a forklift, but I'm guessing it's $15,000 or so for a good solid forklift. And an autonomous version of that would be $100,000. So your payback, if you think that forklift is working for 3 shifts, your payback is something like in 6 months, because I don't have a person that has to operate the forklift. I have essentially saved enough labor to pay for the additional sensors and automation.
Nice. Any other questions? Yeah. Jeannie, do you want to go ahead and ask it? And then Susan's got a question.
Sure. Do you think in the future, like earlier you mentioned how cameras were $10,000, but now you can get a $5 camera for the same quality, that you think robot parts, they might be more common, so they'll be cheaper to produce?
Absolutely. So the robot arm is, again, a great example. Before the sensors allowed them to be used alongside people, the volume was really limited to mostly auto manufacturing, and the volume was maybe 10 to 20,000 robot arms per year. And with the invention of the collaborative robot arm, it's gone to 100,000 or a few 100,000 per year now, and that price has gone down from $100,000 plus to you can get collaborative robot arms now for $15,000, and it's that's at hundreds, that's hundreds of thousands. When it gets to millions, it's probably going to cut in price again by half, and at some point, I suspect we'll have tens of millions, maybe even hundreds of millions of robot arms being used across different industries. So price will come down, absolutely.
Nice. And then Susan seems to have some expertise in Zoom, and she's making a suggestion about audio if you don't have it yet.
Well, let me try it, and then I'll ask Susan if it doesn't work. So tell me if you can hear the audio.
Nope, we got nothing.
Still nothing. Okay. All right, Susan, I need your help.
Can you hear me?
Yes.
So I don't know if this will work, but if next to the mute button at the bottom of the screen, there's a caret. The caret is the little upward tilde.
Yep.
And you click that. And if you choose under select a microphone, same as system, that might work.
Okay, great. Let's see.
There you go.
Nicely done, Susan.
Thank you, Susan. I learned something. That's awesome. Okay, I'll start over.
We still got nothing. Chris, we can't hear.
Say again, Allison?
We can't hear.
You still can't hear? I thought we just tested that. No? Let me try again.
Oh, yeah, let's try again.
It says same as system. Huh. Interesting. Let me try something else real quick.
You want to try one more time?
I do. Are you hearing anything?
Almost.
Allison?
It seemed like it was trying.
Okay, I'll start over again and we'll see if it works.
Nope. No.
No? Allison, no, you're not picking it up?
They're not.
Okay, that's too
Uh,
bad.
do you want to just play the video and you narrate?
Sure. Yeah, it's too bad. I thought we had it. Let's see. Let me try one more thing.
Fulfill their greatest
That was it.
mission, which is doing jobs that are impractical and dangerous for people to do. Build with Robots pivoted and leaned into the disinfection space and created the best solution to disinfect large spaces quickly and safely with the BreezyOne. We knew that Breezy would solve a real problem, and we also knew that it had to work for real people. In order to have Breezy solve a problem for real people that were doing real jobs, we needed a development partner. And we were very lucky to partner with Nika Allen and the Albuquerque International Sunport and their janitorial staff to make Breezy the perfect partner in disinfecting this space.
Hi, my name is Nika Allen, and I'm the Director of Aviation for the City of Albuquerque. I get to run the Albuquerque International Sunport and Double Eagle II General Aviation Reliever Airport. In March 2020, when COVID-19 hit the United States, I could not sleep at night, knowing that I wasn't doing enough to make sure the passengers traveling through the airport and my staff were going to be safe every day. So I felt like I had to come up with a technological solution to really help us make sure that everyone would be safe. We looked at many technology solutions, including UV disinfecting robots, to see what would be the best for our space. We really have a limited amount of time, as many airports do, to actually get this place disinfected. This disinfecting robot has been perfect for our needs. My staff actually has that kind of control where they can decide when and where it goes. They also are able to get all nooks and crannies of places that we would never be able to get with a UV disinfecting robot. We were able to work with a first generation BreezyOne, but we're going to get the new generations as they come out, because working with Build with Robots as a service, we get to continue to upgrade as they upgrade the product.
Thank you, Nika. You guys have been amazing to work with. As part of this demonstration, I'm going to have Chris Zomack, our CEO, explain to you some of the features of BreezyOne.
BreezyOne has two very high power, high efficiency foggers on a autonomous mobile robot base that we partnered with Fetch Robotics, taking their warehousing robotic solution into autonomous disinfecting very effectively and very quickly. Fetch Robotics is a warehousing robot that is used to move materials through facilities, warehouses, distribution centers. It has the LiDAR and cameras and navigation mapping systems that allow it to autonomously navigate, avoid obstacles, reroute if necessary around people or objects that have moved. And we've essentially added the fogging capability to that platform. In addition to the batteries and electronics that we needed for the disinfecting fogging solution, we also had to develop a user interface that was catered towards janitorial staff. So on BreezyOne, we have a graphical user interface on a touch panel that gives the operator the ability to select a restroom or a wing of the airport to fog. At an airport, for example, a gate may close or a restroom may close, and the workers are able to quickly change the workflow through a very simple, easy to use user interface. BreezyOne also has the ability to cloud log all of its data. So while it's navigating and fogging, it keeps track of things like the routes and paths that is fogged in, the amount of fog it's dispensed, and all of the details that a user will be able to look at later to validate performance and efficacy of the solution.
The first thing we do at a new facility is interview the staff to understand their cleaning and disinfecting workflow. One thing we figured out early on is that the system absolutely has to integrate with current operations. While it may not be as complex as aircraft operations, you'll find that a crew that cleans and disinfects 350,000 square feet every night has a very well-defined and optimized process and sequence for getting things done. Our intent is for the robots to operate in parallel with these existing workflows for seamless integration. Once we determine the best sequence for fogging, we use a BreezyOne unit to map and survey the space. The floor plan you see on the screen was actually developed by the robot's onboard sensors. Once we have the spaces fully mapped, our application engineers can program fogging zones and fogging paths and load them into the robot. Once they are loaded and tested, we're ready to go. Based on how we break up the workflow, we define fogging zones and program them into the interface. When ready, the user can fog just an individual zone or tell the robot to fog the entire sequence. Once we've decided what we need to fog, the operator will prep Breezy, verify the space to be fogged is clear, then activate the fogging unit and send Breezy along its merry way. Breezy will navigate to its first starting point, then start its fogging pattern. One of the most important things we do when we're designing your fogging path is swab for total bacterial load in high traffic and high touch areas. We use bacteria as a proxy for viral load because it's easier to detect and they generally occur in the same space. After fogging, we go through and swab again to make sure that we're fogging effectively to disinfect your space and to refine our fogging path. Chemical fogging is the most effective way to kill microbes in a large facility. And chemical fogging with autonomous means is the most cost-efficient way to get this done. A lot of the options that are available right now include UV robots, manual daily cleaning, having an outside service come in intermittently to clean your facility, and now using BreezyOne to do a daily cleaning. You can see on this chart that depending upon the use case and how highly utilized the resource is, the costs vary pretty widely. We've worked really hard to ensure that Breezy is not only the fastest and easiest and most effective way to clean your space, it's also the most cost effective. What we've seen at the Sunport is that Breezy has given the employees the confidence that they can be in this space and that their employer cares about them and is making sure that they're safe.
Knowing that BreezyOne is sanitizing everything before I come to work gives me peace of mind. When this all started, you know, especially everybody's so worried about going to work, and we never stopped going to work. We had to come here every night while everybody got time off. So coming in knowing now that BreezyOne went through and sanitized everything, that we have kind of peace of mind that it's making me safe and my job safe.
Oh, it's going to be nice because it's going to spray the chairs down, the floors, the handles, just it's going to be in the air. I mean, it's going to be nice. It's going to help so much.
People think of us like it's just janitors. It's good to like have someone care about like our safety. It means something. It means a great deal to me.
It's going to give people peace of mind throughout the whole city, the whole country, to just come to any facility and feel safe, feel that the airport is, or any facility is sanitized. So we feel you have peace of mind, you feel safe, and you have nothing to worry about.
Thanks for including us as part of this demo day. We really look forward to working with you soon.
Very cool. And then Susan's asking what specific chemical sanitizer is being used for that. Oh, Chris, you're now we can't hear you.
Can you hear me now? Okay. I'm learning more about Zoom. Thank you. Let's see. So, Susan, good question. So, we use we've qualified a couple different chemicals already. The one that we're spraying at the Sunport is a hydrogen peroxide based chemical formula with a quat. It's a two-part formula that was actually developed at Sandia National Laboratories for decontaminating chemical or biological weapons, specifically anthrax. So it has an extremely high kill rate, but it also is green. It decomposes into water, and oxygen, and essentially soap dust in about 2 hours. So once you mix the chemical and fog with it, it is, essentially the soap, the quad will break down the cell layers, and then the hydrogen peroxide will kill the biological materials. But then it decomposes, and essentially it's safe. You could lick the, not that you would, but it's completely it's green certified. So that's one. We also have a second hydrogen peroxide solution that's a single part formula that a chemical company wanted to partner with us. So they're actually a strategic partner that's helping to deploy the robots with us using their formula. And then we're looking at a third formula from a few different chemical companies right now that's a little bit safer, or how do I want to say it, a little bit more benign around people. Because right now we still have to clear out facilities for about half an hour while you fog, and we have some applications where we don't even have a half an hour. So we're looking at something that has a lower log kill using a different chemical formula, and that's still in the works, but we'll probably have a few at some point.
I appreciate the story of engineering working alongside the workers. So you're really creating a co-worker to help.
Exactly right. So, so our mission, I described early, isn't to just replace people with robots. And I really think that's a misunderstanding of the real shift that's happening. It's, when we invented the computer, it changed the nature of work. There were ledger keepers and all sorts of jobs that no longer existed afterwards. But most of those people were retrained, and we've actually created more jobs than we dislocated. And the same thing's going to happen with automation. And the workers, in all the industries we've been looking at, they don't have enough people wanting to do the things that we're doing, or they can't. So Breezy, it moves when it's moving at the fastest pace in a really large facility. It moves at what kind of like a human jogging pace, and it carries 10 gallons of chemical, so 80 pounds of chemical, and has 2 foggers. So it, in order to disinfect a space like the Sunport, where there's a very short window in between when they actually have people there. So believe it or not, there's people at the Sunport 24/7. The janitorial staff is there, but even the gate workers and the airplane workers are there very late, and then they get up very early. So there's a very short window in which we need to fog, and you can't do that with people, because you'd have to have 10 people that work for 2 hours a day in the middle of the night. So the options are to do nothing. I mean, that's what we're finding is most places are doing nothing. And it's, this is a better solution than doing nothing. And I'll tell you, it's really interesting is if we do the biological sampling that you saw in the video. If you go into the Sunport now, you can't find biological material anywhere. I mean, it's impossible. We've tried to. We actually now have to go and bring our own in. We bring in these little, essentially squares that have biological, growing on it, bacteria, and we use that pre and post fogging to do our demonstrations now, because they're just the amount of protection that we put in there over the last few months has made it completely, all the surfaces are germ-free.
And pollen-free. That's awesome.
Pollen and everything else. It's actually, people have asked us about asthma, and we don't have any data yet, but my sense is, for schools is one of the areas we're looking at. In schools, we would fog, hours and hours before people showed up, so the chemical would be completely gone. But it would kill all of the pathogens in the air, including pollen. I suspect we'll have less cases of asthma in schools if they're disinfecting.
What other questions do y'all have? What about the restaurant robots? You showed the one picture of the hamburger flipper.
So we looked at that and worked with a company, a startup here in town, and helped them out. And the one area that they kind of focused on after doing some discussion was food prep, and doing it in kind of like a ghost kitchen where you're doing food prep for a lot of different facilities, or a lot of, a chain that has a lot of stores in one location, and you could do the food prep. So, think of like, most restaurants want fresh vegetables, and it's very costly to have people chopping, and also you're using knives, so, chopping tomatoes and, vegetables is something that you could do with a robot. The economics of it, and just the whole, you're in those situations, there are a lot of, high school kids will do that work. So it wasn't a great fit, as it turned out, from what we could tell, because there was a labor pool that was happy to cut vegetables all day long, and it wasn't an industry where it was as dangerous or as dirty or impossible for people to do what the automation could do.
Tina, you have a question.
Yeah, my children and I are wondering how long it took for Breezy to be developed and then deployed at the Sunport.
Good question, Tina. So we know a lot about robots, and we knew and have relationships with lots of different component suppliers, so different sensors and different robot arms, robot autonomous bases. So we kind of knew the pieces, but we still had to build it and put it all together. And we partnered with the chemical company that has the Sandia chemical that we mentioned earlier, and we partnered with a fogging manufacturer out of Florida. As it turns out, in COVID, those foggers that spray fog the disinfectants were actually harder to get than toilet paper was in the early days. So we actually signed an agreement with them to provide us hundreds of foggers. And so putting all those pieces together was actually the first challenge. And that took maybe a month to figure out all the suppliers and partners. And then the engineering team that we have put together the units you saw in the video in about 2 more months, 3 months total. We went from this is something we can do and help the community with, to having robots at the Sunport. And then that initial version that we showed, we built those in a small quantity and did early customer trials with them. And then we're right now in a redesign for mass production. So we have a new revision that will be released in about a month's time that we're building in much higher volume.
Good questions. Keep it coming.
So my sense, Tina, you have your children with you. My sense is that things that are very repetitive in nature, and things that are really dirty, like disinfecting fog. Also, we've done enough disinfecting. You got to wear hazmat material, PPE. You have to carry a lot, backpack. You're doing a lot of spray. And that's not easy work. Those type of roles are going to disappear from for our children. And really our children should be thinking about, you know, more of the more interesting work anyways. You know, my last company, we sold semiconductor and radio test instrumentation. So we sold into the large Foxconn and Pegatron factories in China that were doing testing of phones, and they would have, you know, Chinese kids, you know, 19, 20, 21-year-olds that would come in and work 12 hours a day, actually 11 hours and 45 minutes because they had a 15-minute changeover. So 2 shifts, 7 days a week. And they essentially did robotic work all day long for all year long, actually. And they never had a day off. But they, all those factories are now using robots because partly the economics are not really there yet, but the Chinese kids don't want to do that work anymore. It's just, you know, no one wants to do that is the thing, is what I saw. And that's the world's really going to change from low-cost labor to regions that have access to raw materials are going to be important, but also access to talent. You know, people who are comfortable with automation and know how to program and how to 3D print and how to, you know, use machine tools to rapidly build up things like BreezyOne, like we did. So that's, you know, part of our mission is to build out the local community here and help train up workforce. We do a lot with UNM and CNM and other institutions here in the state. Explora, plug to Explora.
Let's have the code word be cobot, a co-working robot. And we have one more question. Where will Breezy be deployed?
Well, yeah, so right now we're deployed at the Sunport you saw. We're at a nationwide data center. We're in trials at large distribution centers nationwide, and in Texas, we're in a factory. One of actually the world's largest factories in Texas is using us. And we're also through a partner in Texas working with the school districts and trying to get into schools. I would love to be doing helping our kids here get back into school. I wish my kids were in school, at least part-time, but our priority is not there yet in New Mexico, whereas Texas has made it a priority. So their kids will be back in school, and Breezy will be helping them get back to school safely.
Yeah, those are interesting considerations on whether or not to open a school. Let's give Chris a huge thank you. Let me also give our sponsors a huge thank you for making Science Fiesta possible. Please fill out the feedback form. We're doing daily drawings for gifts. Our sponsors for Science Fiesta include AFRL, Fidelity, New Mexico EPSCoR, HP, Acma, Blue Cross Blue Shield, Facebook, Sandia National Labs. If you feel in the mood to share via social media, here are some hashtags for you to use. And again, a ton of stuff going on throughout the week at the Science Fiesta website can be found here, explora.us program Science Fiesta. Again, the feedback form, bit.ly/feedback sci-fi. And let's give a huge shout out and thank you to Chris. Thank you so much.
You're welcome, Allison. Thank you. And thank you, Explora, and to everyone who participated. I appreciate your time.
Thank you. You are so welcome. If you all are interested in weather, there's one more presentation this afternoon on how to become an amateur weather forecaster. Bye, y'all.